Hi folks, this is the 19th problem of the DSA series, so let's get started. It says evaluate reverse Polish notation. Okay, so you're given an array of string tokens that represent a valid arithmetic expression in reverse Polish notation. So first of all, what is reverse Polish notation? Reverse Polish notation is a way of writing mathematical expressions where operators come after their operands instead of between them. For example, see this, right? Plus here came after these operands, after 1 or 2, not before them, right? So how do we solve this? This is an RPN, reverse Polish notation. We do 1 plus 2, 3. Then these all are converted to 3. Now here assume we have 3 from 1 plus 2, and here we already have 3, and now this operator is after these two operands, 3 and 3. So 3 into 3, 3 into 3, 9. Now assume all of these become 9. Now we have 9, all of this became 9. Now we have 9 and 4, and here we have minus, that is operator after these two operands, 9 and 4. So we do 9 minus 4, 5, right? So we'll do, here you can see the explanation, 1 plus 2 into 1 plus 2 is equals to 3, then 3 into 3 is 9, then 9 minus 4 is equals to 5. So this is how we write in reverse Polish notation, right? So what we got to do, we got to solve the reverse Polish notation. Here it says return the integer that represents the evaluation of the expression. This is the expression. The operands may be integers or the results of other operations. The operators includes plus, minus, multiply and divide. Assume that division between integers always truncates towards 0. That is, let's say that is, if we have something like 2.76, we'll consider it as 2. We'll truncate whatever is there after the decimal places. This is what this line means, truncate towards 0. Okay, so yeah, let's get started. Let's write a function evaluate RPN. Here the array, we'll call this array the tokens, as it's being said here. Now in this array we'll have these elements in the string format. So what I'm thinking of doing is, we'll take a stack is nothing but an array, and we'll map over this. We'll see if we encounter an operand, that is 1, 2, 3, whatever, that is, if we encounter a number not an operator like plus, minus, then simply push that into that stack, right? However, if we encounter an operator like plus, then what should we do? We'll simply pop the last two elements from that stack and apply that operand on it. That's it, right? So let's do it, and you'll understand it much better. So we'll say first let's have this const operators. So I'll make it a set, new set, and here we'll have all the operators, so that we'll check while mapping over this if it's an operator or an operand. So we'll have multiply, and then we'll have divide, then we'll have divide. Okay, now we can have const stack is equals to an empty array. Now let's map over it. For let token of tokens, here we'll check if operators dot has. So this is why I took the set, because dot has is an O of 1 operation. Instead of, here I am just checking this if it is present. Instead of this, we can simply do or, like or here. If token is equals to plus, or token is equals to minus, or token is equals to multiply, or token is equals to divide. So instead of this, I just took a set and checking here. So if the operator is present, so if So it is not present. That is, if an integer is present, then simply push that integer onto the stack, right? And let's also convert it into the number, because here you can see these are all in the string format, right? We'll get in the string format. So yeah, we'll push in the stack if we find an operator. If we didn't find an operator, that is, if we found a number, we'll simply push it onto the stack. If it's not the case, then we'll simply pop the last two elements, right? We'll say const write, and then we'll do tokens dot pop, because this will give us the rightmost element, this is topmost element from the stack. And I'll do const left is equals to not actually token, sorry, will pop from the stack, right? Here we are pushing into number into stack. If however, if we encounter an operator instead of number in the tokens array, then we'll simply pop from the stack dot pop, right? This is the topmost element of the stack. This is the second element, second from the top from the stack. So we'll say right, and here we'll say left. Now if this is the case, then what we'll do is we have right we have left, we got a push into the stack as well, right? See, we encountered this. Now we got, and we have like 1 2, so we pop 1 and 2. Now we got to push 3 into the stack. 1 plus 2 is 3. We got to push 3 into the stack. So in the next iteration we'll have 3 and 3, and we'll push 3 into 3 onto the stack, right? This is what we'll do. So we'll check if token is not a number, because we already know it's an operator. Here we checked for that. If it's a plus operator, then simply do this, simply do stack dot push left plus right. Else if, now like do it for all the cases. If it's minus, then simply do stack dot push left minus right. If it's a multiply, then simply do left into right. If it's a divide, then simply do left divided by right. However, in this case we got a truncate whatever is there on the right side of the decimal. So we'll do math dot trunc. Yep, this is what we will do. You understood, right? So what we did is simply this. We took this. Now we simply made a stack, and here in the stack first we pushed 1, then we pushed 2, right? Then we encountered plus, so we popped these two, right? So the stack became this, right? So the stack became this, we popped this, and now we'll do, and we saw, okay, so we encountered plus, that's why we popped, and we'll add 1 plus 2 3, and then we'll push it into the stack. So 3 is pushed into the stack. Now in the next iteration, what will happen? It will check, okay, next is 3. Is it an operator or an operand? It is an operand, not an operator. So we'll simply push it onto the stack. We'll simply push it into the stack. Now we'll go one step further. Again, this loop will continue. It will see, okay, we encounter multiply. Is it an operator or an operand? It is an operator, obviously. So since it's an operator, we'll again pop. So we again pop 3 and 3. So again we got this empty stack. We had right 3, left as well as 3. and now we have multiply, so we'll do left into right, that is 3 into 3 9, and that will again push onto the stack. So we got 9. Now our loop will move forward. Now we'll encounter 4. Is it an operator or an operand? It is an operand, so we'll simply push it onto the stack. Now we got 9 and 4. Okay, now again our loop will move forward and will encounter minus. It is an operator or an operand? It is an operator, so we'll get into this else part. This else part will pop the right as well as left. This is the right, this is the left. So now we'll get an empty stack, right? And this is, here we have minus, so here in the minus we'll do left minus right. What is left minus right? We popped the left and we popped the right, so 9 minus 4 is 5, so we'll get 5. This is how it will work, right? And now simply we'll get something like this. So in the end, after this loop ends, we'll simply return whatever is at the 0th index in the stack. That is the first element of the stack, right? So yeah, this is done. It has the time complexity of, you guys can tell me what's the time complexity of this? It's easy, right? It is O of n, since we are iterating only once. So the time complexity is O of n. O of n. And what is the space complexity? Again, space complexity is O of n as well, right? Because we only have this. This is constant. Yeah, so space complexity is again. So space complexity will be again O of n. Right, now let's just test this very quickly if it is even working. Tokens, and yeah, we'll take this soon. Sorry. Tokens, yep, it got us 5, so yeah, it's working. So yeah guys, that's all from my side. If you love this video, I'll really appreciate if you hit that subscribe button. Thanks for watching.